Hello, Kumar.
Yeah, Sangamesh, just I will make you as a host. 1 minute.
Okay, sure.
Yeah, you can start recording.
So let me start recording. Okay, I think the session will beautiful, beautiful. I think we have every single person in this particular room, isn't it? Just give me confirmation.
Yeah, yeah.
Yes, sir. I'm here.
Yes, sir. Beautiful, beautiful, beautiful. Thank you very much. So in this particular session, what we are going to understand is we will try to understand the various other aspects of what I can say, data science and data analytics. So in our previous session, I just want to give you a small recap so that we are on the same page. So in our previous session, we have understood what is meant by data analytics. Okay, what is the definition of data analytics? We have also tried to understand the various roles which are associated with data analytics. And last but not the least, we have also tried to understand, okay, what is what is this particular hierarchy of data analytics. So what is descriptive analytics, what is predictive analytics, what is prescriptive analytics? So this is something that we have understood in our previous session. Okay, so these are the things that we have understood in our previous session. So now what I'm actually trying to help you out is, so today in this particular session, we will be trying to understand a few basic concepts of something called as data analytics. That is majorly related to something called as statistics. So please make sure I'm not getting into the entire statistics, but I'm just going to give you a complete understanding on the basics of statistics. So here I'm speaking about something called as descriptive analytics. Okay, so I want to refer this particular, I think I'm going to share my screen. Okay, please let me know if you are able to see my screen. So if you remember, okay, in our previous session, we discussed about something called as hierarchy of analytics. And in this particular thing, we had a small box called as descriptive analytics. So today we are going to concentrate on this particular descriptive analytics. What is meant by this descriptive analytics and what are the various aspects of descriptive analytics? And please make sure when I'm speaking about descriptive analytics, okay, descriptive analytics is completely, what I can say, related to the descriptive statistics. So when we speak about statistics is divided into two parts. One, we have something called as, okay, descriptive statistics. And second, we have something called as, what I can say, inferential statistics. So today in this particular session, we will be speaking about descriptive statistics itself. That is one of a part of statistics. I hope people got some clarity on this particular part, what we are going to understand. And meanwhile, okay, as I previously told you in the previous session itself, I want every single person to switch on their what I can say, camera as well. The reason is, okay, I hope you can see me, okay, and I also want you to see you. So for that specific reason, I can see that only one person from this particular room have switched on their camera. Thank you very much. Bhunesh. Sure. Adding to this, to start this particular session, what we have to do is we have to go for two things. Number one, we can use Excel, or Google Sheets, these kind of things, to understand things really well. Or else what we can do is we can use Python itself. Okay, so now before I jump into the entire, what I can say, Python or Excel or these kind of things, I just want to give you a small brief, what is meant by basic statistics. I'm giving you a small understanding that anything that we are going to do today can be done on Excel, can be done on Python as well, but I'm just giving you a small idea so that you are clear with the theoretical concepts. You are clear with the theoretical concepts. So today what we are going to do is, today we are going to understand something called as I've told you, statistics. Stats have two different types. One is called as descriptive. Okay, descriptive statistics. And second is, it is called as inferential statistics. See, when I speak about descriptive statistics, today we are going to focus on this particular part. See, hope you are able to recall when I told about descriptive statistics, okay, what are the things that we are going to learn? Or what are the things that we are going to discuss? Can anyone recall? Can anyone help me out with what are the parts that a descriptive analytics is going to help us out? Anyone is able to recall previous session?
Yeah, something it is related to interpret the data in descriptive analytics.
Describe the data you are speaking about.
Describe the data, what the data exactly is. It is a
Okay.
carrying in raw state. Yes.
Then
The initial level of the explanation, we can say so. Suppose
explanation, beautiful.
any patient going to doctor. So as you told, given an example this day before studies class. So patient explaining actually what is happening, and doctor is in that. So that is the thing. Initial level
Yes.
of explanation we can
Yes.
describing the initial level.
Good job. Good job. Yes, you're absolutely right. Here, descriptive statistics is all about describing the data or describing a specific column. So for example, let's assume you have a column called as age. So you have various people like you have names here. Okay, names. We have Amjad, we have Ansari, we have Akshay. Okay, and we have Suma. Okay, Kavita. So we have certain names here, and we also have age as well. So we have 15, we have 20, we have 25, we have 30, 35, something like this. So when I have this kind of column, okay, so I have a column called as name, I have a column called as age. When I speak about descriptive statistics is all about, okay, how many Amjad we have in this particular column, how many Kavita we have in this particular column, okay, how many this thing, what I can say, Suma we have. Basically we are going to speak, okay, Amjad, this particular name is occurring something like 3 times. Suma is occurring only 1 time. So this kind of analysis. So what we are going to do here, we are going to do something called as count. Count of Amjad, count of Suma, count of Kavita, something like this. I hope people are getting some clarity on this particular part. Similarly, descriptive statistics, we also try to understand the age column. So in this particular part, we have to understand something called as data type. We have to understand something called as data type. So there are various types of data. Okay, we will be trying to understand what are the different types of data that we have in descriptive statistics. But what I'm actually trying to say is, okay, so here we have a categorical data, anything which is in text. In programming language, in coding language, many people call it as string as well. String, not the string that you drink. Okay. So there is something called as string. It's a data type. So you have something called as, okay, what I can say, string, which is also called as text, which is also called as what I can say, a numerical column. Oh, sorry, extremely sorry, the categorical column. This is your categorical column. Name is a categorical column. Similarly, when you also have something called as age. Age is what? Age is your, okay, numerical column. Number. So if you are from programming language, so there is something called as float, there is something called as integer, there is something called as, what I can say, various other things. Okay. Anything, any data type that is described in this thing, what I can say, number, it is called as numerical column, numerical column. So these are the major two types of data types. So along with other, along with this, there are also other types of data types like ratio, okay, factor, okay. There is, there is also something called as this thing, what I can say, this thing, Likert scale. So there are various types of, data types. Many people call it a Likert scale as well. So people who are from abroad or people who are from outside India or something like that, they tend to call it as Likert scale as well. But Indians call it as Likert scale. Okay. So these are the various types of other types of data types that we are not going to discuss in this particular session. But there are other types of statistical data types. See, look at this. When I speak about data, when I speak about data types, okay, so there are data types that are programming language. Because when we speak about Java, when we speak about Python, when we speak about R, when we speak about, Excel, they have a specific data type. Okay, in Excel, I don't know how many of you know Excel really well. So in Excel, we have data types, we have data type, we have text, we have numeric. Similarly, this is only limited to Excel itself. Similar to that, we have something called as R programming. There we have factors, characters, we have integers, okay, and these kind of things. Python have float. So every single programming language do have a different data type. But similarly, even statistics is also having a specific data type. So here in this particular session, what we were speaking about, I was speaking about something called as mean, median, and mode. So this mean, median, mode are the part of central tendency or of something called as measure of central tendency. Let me say new this thing. Let me explain this. Measure of central tendency. So when we speak about measure of central tendency, okay, we have this particular mean, median, and mode. See, when I speak about this mean, median, and mode, it is called a central tendency. And now many people might be asking me, Sangamesh, why it is called a central tendency? Why we are using this word called as central tendency? How many of you have this particular question? Say I on the chat. How many of you are having this particular? Sorry, why is this mean, median, mode is called a central tendency? And what is meant by mean? What is meant by median? What is meant by mode? That is also something that many people might be having. How many of you have this?
Sir, actually, this is a part of stats. Mean means simply average.
Yes, agree with you.
Yeah, and I am unable to recall the median and mode. I had studied in 11th, 12th.
Yes, 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 yes. Every single person who is in this particular room, they have studied this, but unfortunately, no one recall this or no one remember this. But this is a kind of a revision as well. Okay, we will be able to help you out. Okay, in my perspective. Okay, so we have mean, which is basically an average. Okay, like for example, if you have, if you have a list of variables, like let's assume you have a column called as age. Here you have various age, 18, 15, 20, 25, 26. When I ask you a question, okay, okay, describe this particular column, okay, it will be really difficult for you to understand, which specific number we have to provide. So for that specific reason, every single person, what they do is they tend to break this particular part into something called as average. They tend to break this particular part called as average, ABG. See, here, this average is basically a mean. That is basically a breakdown of this particular column into the more simpler aspect. So there is highest, there is lowest, okay, which is going to be on an average. Average means the sum of all this particular column divided by, basically the total number of values. I can call it as total count. So if you are able to do that, you are going to get something called as average. This is something every single person know. But what is this median? See, this median is something called as mid value. It is called as mid value. It's a nickname that we normally provide. So let me take an example here. See, what I can actually do is, if I try to plot all the age and its count into a plot, it is called as histogram. So the histogram may be something like this. I'm just giving you a small idea. So here, when I speak about, what I can say, mean might be somewhere here. But median is the one which is always going to be in the middle. It will be always in the middle, right here. This is your mean and this is your median. Here, mean is nothing but an average, but median is basically your mid value. And along with that, you also have something called as mode. You have something called as mode. Mode might be somewhere here. Okay. So this mode is going to give me the most frequently occurring. the most frequently occurring number. I will give you an example. So for example, let's assume we have a number, like these are some kind of numbers like 10, 15, 20, 10, 10, 10. So here, the one which is going to repeat multiple times, it is going to be called as mode. So here, you are able to see 10 is the number which is repeating multiple times. So for that specific reason, mode will be the 10. Now you might ask me, hey, Sanmesh, why do I need to learn all these things? Mean, median, and mode. Huh? What do I do with this mean, median, mode? This is a question that you have to ask me. Why are you teaching me this mean, median, mode? What do I do with this mean, median, mode? How many of you have this particular question in your mind? Application of mean, median, mode. Where do we apply this? Huh? You're teaching me statistics, mean, median, mode that I have learned in my school itself. What do I do with this? How many of you have this kind of question? Just say I on the chat. Meanwhile, okay, Bhunesh as well as Akshay, please turn on your camera as well. Please turn on your camera as well. We request you. And we also request you to be a little bit proactive and a little bit interactive on this particular session. See, now we will try to understand, now we will try to help you out with this particular part, that is this particular thing, mean, median, and mode. And how it is going to be useful. So I will basically show you a visualization from Google so that you will be able to understand this better way. But yet, I'm just going to give you a small brief, okay, understanding this particular mean, median, and mode. See, when I speak about mean, median, and mode, it is always going to help us out to understand something called as histogram. It is able to help us out to understand something called as histogram, how the data is dispersed. What is meant by this word called as dispersed? Dispersed means sometimes, look at this, sometimes the data might be dispersed in this particular fashion, right skewed. Sometimes the data might be dispersed in this particular fashion. Sometimes the data might be discussed in this particular fashion. Sometimes the data might be dispersed in this particular fashion. I'm speaking about the dispersion of the data. Dispersion of the data means how the data is distributed. Please connect with me. This is a very critical and this is one of a crucial step that you are going to learn. Okay, feel free to ask me if you are not clear on any specific part.
It means that the data varies.
Sorry?
It means that the data varies.
Yes, you're absolutely right.
Variability of
Yes.
data.
Yes, data varies a bit.
In different variation.
So for example, if I have a column called as age column in one data set and age column in a different data set, okay, the dispersion of it basically means if I'm trying to plot a histogram, okay, the histogram may be different. Okay, and there are various types of distribution that a histogram tend to provide. Okay, and here we try to understand what type of distribution it is going to have, understanding this mean, median, and mode. Give me a small minute. Give me a small second. Give me a small thing. Like what I will do is I will try to go ahead and try to get my Chrome. Look at this. Look at this. You have mode here. You have median here. You have mean here. Negatively skewed. If mean is mode is greater than median and median is greater than mean, we are just going to say that as negatively skewed. Now you start to think like a statistician. Now we'll start thinking like a statistician. Look at this. Here, mean is the highest, median is the lowest, and okay, mode is completely lower than all these things. By looking at this, you are able to see that this is positively skewed. And similarly, if mean, median, and mode are same in that particular case, we call this as no skewness. Really interesting, right? Really interesting, right? These statisticians that you see, they are very smart. They are very smart. So we see these kind of information and we try to decide how the data is. Okay? How the distribution of the data is. Now you might be saying, hey, Sangamesh, what are these funny distribution? Why do I need this? What do I do with this in data analysis? Many people might be having this kind of questions as well. How many of you have this kind of question? Say I on the chat. I on the chat. This distribution is very important. This distribution is very important. The reason is if there is, okay, rightly skewed data, leftly skewed data, there are certain data analysis models that cannot provide you the right value. So sometimes there are some data analysis models which need to be normally distributed. Look at this. There is something called as normally distribution. We will be trying to understand this normal distribution in a detailed aspect, but there is something called as normal distribution. Okay, so the data need to be normally distributed here. Okay, and in this particular scenario, what is actually going to happen is I cannot give a data which is right skewed or left skewed there. I need a data which is in the middle, like a kind of a semantic distribution model. So if you try to give a model like right skewed or left skewed to those kind of data science model, the data science model will poorly perform. They are not going to give you good accuracy. Okay, so for that specific reason, we do this particular kind of what I can say, measure of central tendency. We will try to look into this particular part, measure of dispersion and all these kind of things. I hope people are able to understand what I'm actually trying to help you out. So what we are trying to understand is the descriptive statistics parts, and along with that, we are also trying to understand the central tendency as well. So that is what is meant by central tendency, what is measure of central tendency, and along with that, we will be trying to understand something like measure of dispersion as well in couple of minutes. But before I proceed ahead explaining, look at this. I want to show you few more instances how this mean, median, and mode are going to help us out. So look at this. By seeing this mean, median, and mode, we will be able to understand how this is performing. And look at this. If there is any kind of outlier or something like that, the distance between the mean, distance between the median, and distance between the mode will tend to vary. Okay, so these are some kind of instances that we are going to look into and try to understand. See, when I speak about this outliers is a very simple thing. Okay, let me help you out on this. So for example, every single day we used to use this hand wash, right? Alcohol-based hand wash. Okay, these days it is not common. But recall when we had COVID wave 1 and wave 2, We used to use hand wash hell amount of. Along with this is mask. No one used this mask. Okay, people who used to be in metro cities, okay, who used to be in Bangalore, what I can say, Delhi, or these kind of metro cities, they tend to use this mask because the pollution level exceeds really high during those times. So they only used to use these masks because the AQI is really bad. Similarly, right now, no one is wearing mask. Agree with me? No one is wearing mask. If I go, hardly 1 or 2% of the Indian population is wearing mask. Hardly. Okay, who are having cough and fever, only they wear. Even my wife is having, cough these days, but she's not wearing mask. So this is kind of scenario that we are able to see these days. See, what I was actually trying to say is, we have mean, median, and mode, which is being distributed in such a way. Now what we have to do is, we have to understand something called as a type of distribution that is called as normal distribution, which is also called as bell-shaped distribution. Which is also called as bell-shaped distribution. So this is not me. You see, I don't want to take any blame. This is basically described by many statisticians, and there are also a lot of, what I can say, there are also a lot of people out in market. Okay, they have written a lot of white papers, research articles on this particular part, that is something called as normal distribution. So one of the crude way of calling this as normal distribution is the data will look like a bell-shaped curve. Bell-shape, ghanti. Okay. So if you look at this, it is going to look like a bell itself. So for that specific reason, it is called as normally distributed. And there has been a lot of, what I can say, research which was being conducted. And what they say is, what bell-shaped curve try to say us is, the entire universe, okay, the entire universe, you should try to take the probability of these things. They normally try to fit in a bell shape, that is a normally distributed fashion. This is something which has been described. And if we try to see our school also, if we try to see our school, when we were in school, we also had everything in a bell-shaped curve. So let me take instances of your school itself. So in your school, let me say I'm just going to draw a bell-shaped curve. I'm really bad at drawing. Okay. So let's assume that this is bell-shaped curve. Let's assume this is a kind of a bell-shaped curve. So these bell-shaped curve is been divided in something called as first standard deviation, second standard deviation, third standard deviation. Okay, I'm also really bad at drawing. Sorry, pardon me. See here, what I was actually trying to help you out is, okay, so there is the extreme part. Let me discuss this extreme part. That is basically called as the, what I can say, standard deviation number 2. So you have central tendency, which has been broken down into a couple of parts, okay, which is called a standard deviation number 1, standard deviation number 2, okay, standard deviation number 3. Standard deviation. Let's go back to our school. Every single person in this particular room had been, had an opportunity to go to school. And in your school, if you take out the most intelligent people, a person who tend to score something like 100 out of 100 on all the subjects, how many people we had these kind of people? Hardly 1 or 2, right? Hardly 1 or 2, right? In your entire school. Agree with me. 1 or 2. Agree with me? From your entire population, from the entire people in your school, hardly 1 or 2 people will always score 100 out of 100. Agree with me? Similarly, a person who is going to score lesser than 20, like Tare Zamin Par Ishan Avasti, hardly 1 or 2, right? Hardly there will be 1 or 2 people, not the entire population. So for example, if you conduct a random test, okay, so there is 1 or 2 people who are going to score really good, and there are also hardly 1 or 2 people who are going to score very less. Agree with me? Feel free to discuss this particular part. If you are going to contradict me, no. In our school, we didn't had anyone who used to score lesser than 20. You can debate with me. But on an average, this is a type of scenario that we tend to see. Wherein there will be very few people who are going to be really bad at studies, and there are very few people who are going to be really good at studies. So we try to basically use the marks here in the y-axis. Sorry, x-axis, extremely sorry. This is called as x-axis. And in our y-axis, we try to get our, count how many of the people who are scoring this particular thing. And unfortunately or fortunately, there are extreme instances. This is your poor people, poor study people. So this is your people who are toppers. Your Albert Einstein, Abdul Kalam, these kind of people. These are the people who are going to be here, and these are the people who are going to be like Ishan Avasti, Tare Zamin Par. Okay, they are going to be here. The average, that is my mean, median, and mode. All these things fall under something called as first standard deviation. The center of this particular this thing. So that is also one reason why it is called as central tendency, because it is bound to fall in the center of the standard, first standard deviation. I hope people are able to identify what I am actually trying to say. Now, many people might be asking me, Sangamesh, what is this standard deviation? I haven't heard about anything. I'm able to recall. There is something called a standard deviation, but I'm not able to exactly understand what is meant by standard deviation. Anyone is able to recall standard deviation? You can give a crude understanding. Yes or no on the chat. Abhishek, he nodded his head like this. I'm able to get it. Okay. Amzad, anything if you are able to recall? I think you're on mute, sir.
Not really.
Not really. No worries, no worries. I'm here to help you out, right? So now let us try to understand something called as standard deviation. See, when I speak about standard deviation is a number. So you normally get a standard deviation like 5, 10, 100, 200, 300, okay, 1 lakh, something like this. What are these numbers? Why do I need these numbers? Look at this. These numbers are very important. These numbers are very important. The reason is these numbers are going to give me clarity on okay how to see the dispersion is. what I'm going to do is standard deviation, high versus low. Look at this. So if you have a standard deviation, I think, okay, standard deviation which is low, you have a standard deviation like this. If you have a standard deviation which is very, very high, it will be like this. What is the standard deviation? This is something which is going to handle your curve. Look at this. There is a standard deviation which is 10, which is in the middle. Now, if you have a standard deviation which is very, very high, look at this. Minus 2 plus 2. Okay, look at the standard deviation. And if your standard deviation is little bit low, okay, it will be something like this. The dispersion of the structure of this particular histogram is being controlled by your standard deviation. What is meant by this deviation? What is meant by the standard deviation? Let me try to help you out. Oops, I close it? Oh my God, no worries. Okay. This standard deviation is called as fluctuation. If you have a high standard deviation, okay, if you have a high standard deviation, you have something like this. Let me show you a low standard deviation. This is your low standard deviation. What is actually happening here? Try to understand this. So here the range is high. I'm using a word called as range. What is meant by range? Range means lowest and the highest. It's called as range. Lowest and the highest is called as range. Try to understand what I'm actually trying to show you here, guys. Okay. Here, I'm speaking about lowest and highest, and we are speaking about something called as deviation, standard deviation. If the standard deviation number is high, if the standard deviation number is low, we are able to see something like this. And 99% we are speaking about something called a standard deviation. The reason is here we also have something called a standard deviation. And along with that, we also have something called as variance as well. Standard deviation and variance. So if I basically show you the formula of standard deviation and variance, both are absolutely the same. Both are absolutely the same. You are having a square root on it. You are not having a square root on it. So many statisticians believe that standard deviation is better than your variance. Variance will catch lot of noise. Look at this. Variance will catch lot of noise. So for that specific reason, most of the statisticians tend to use standard deviation itself. Standard deviation is one such number, okay, which is going to give you a understanding on the fluctuation. If there is too much of standard deviation, too much of fluctuation. Along with that, when I speak about standard deviation is going to alter my this thing as well. What I can say, distribution as well. See, when I have standard deviation number 1, look at this standard deviation number 1. So it is going to be in my center. This standard deviation is also going to be divided into parts. So when I see this particular thing, so this is going to be divided in the first standard deviation. So the standard deviation is this particular part. So whenever you are going to get a standard deviation number like 200, 300, it is basically describing this particular, the central part. So if you multiply it by 2, you are going to get the, okay, what I guess the second standard deviation. That is going to be this particular range. And this is going to be your third range. This is going to be the third part of standard deviation. Here, what I'm actually trying to do, or here, what I'm actually trying to say is, okay, if you try to look into this particular this thing, the top people, the toppers are going to be here. The poor people are going to be here. And along with that, the people who have above average. We use this word called, right? Okay, in our school, he's the above average student. He's a above average student. He's a below average student. The above average and below average are something which are here. I hope people are able to understand what I'm actually trying to say. Above average and below average. This is why most of yours, class, students or your faculties tend to use, hey, you are an above average student. No, you are an average student. You are a below average student. So this is what they tend to mean. Now I think people are able to understand, okay, this particular metrics, isn't it? We can also decode this particular thing into, okay, the highest people, poor people, BPL, below poverty line. Okay, we can also understand people who are billionaires, millionaires, rich, and all these kind of things. And we are also able to understand what is meant by middle class. We hear this word called as middle class a lot, right? What is meant by this middle class? Okay. Over to you guys. Any questions? Any questions? If you have any questions, do let me know, or else you can type
Yes,
no
sir.
on the chat.
I do have. Sir.
Sure, ask me.
Sir, in initial phase, when we started today's class, that you told two columns, categorical column and numerical column, along with string. So which is string, categorical column or numerical column?
Both are correct. See,
Both
the
are
way
string.
how we use,
Oh,
sorry to interrupt you, Amjad. Okay, the way how we use is different. If we have a categorical data, in that case, we are only going to see the count. So in that only count, we will be able to see only the mode. Okay, so we are going to do that. If we have a numerical column, there we are only able to do mean, median, mode, standard deviation, and all this kind of thing. So anything that I'm discussing, it is only for a numerical column. You cannot create a numerical, sorry, you cannot create mean, median, mode for a categorical data. That is your text data. Agree with me? There you have only one option, that is going to be count.
okay. Sir, do you suggest us to buy some, small stat book to recall?
Amjad, I think your voice is a little bit distorted. Can anyone help me what he is trying to ask me?
Now, am I clear, sir? Am I audible?
Yes, you are loud and audible. Yes, you are absolutely right. Can you go
Sir,
ahead
I'm
like
saying
with
that,
the same face?
do you suggest us to buy stats book to recall the formulas, to study the stats?
Good job. Yes. So I have a book. It's called as RS
RS Sharma?
quantitative. Yes. I basically prefer this. Not quantitative.
RS Agrawal.
No. I used to use statistics, but I have this particular book of statistics. It good?
RS Agrawal.
Yes, I used to use this particular part. The book, what I have, I will try to recall that particular book, but as per my knowledge, I think it was RS Agarwal. But I don't know. Let me help you on this particular book's this thing. So it's a hefty book. It's a book which is of this size. Okay, you can buy it. Okay, it's not going to be a waste of money, because the reason is, okay, if you are going to buy it, your cousins, okay, your children's will obviously need them. Not today or tomorrow, they will require this. I hope you are able to get this particular part.
Oh, okay. All right.
Okay. Your cousins, your children's, your grandchildren's, maybe the entire generation may require this particular book. It's not a waste of money. I will try to help you out with this thing. What I can say, I'm not able to recall the author. If possible, I will try to show the same thing tomorrow. Okay.
Sure, sir.
Sure. So without wasting any time, let me recall what are the things that we have learned. Okay. So in a layman's aspect. So today what we have tried to understand is, we have tried to understand something called as data type. Okay, data types of statistics. Second, what we have done is, today we have also learned something called a central tendency. We have learned something called a central tendency. Number three, this is number three, extremely sorry. This is number three. We have also learned something called as measure of dispersion. Measure of dispersion. And number four, we have also tried to understand some graphical visualization, okay, or graphical techniques which can be used to understand, okay, the mean, median, and mode. Okay, all these things that we have understood. And last but not the least, we have also tried to understand the descriptive statistics, descriptive analytics. So these are the things that we have learned in this particular session. Okay. See, there is one such thing that I want to give you a small idea. When I speak about this particular graph, look at this. When I speak about this particular graph, we are discussing only a specific graph called as histogram, and I was speaking about histogram a lot. But a statistician also use another type of visualization. So this type of visualization is actually called as box plot. I don't know how many of you have heard about this box plot. If you are from a stock market trading, okay, if you do technical analysis, you will be able to see this. So you have something called as inner quartile range, IQR. This is also one of a terminology what a statistician tend to use. Array, nothing to be worried. Nothing to be worried. This is the same. Let me show you box plot and box plot. Array, what is box plot and normal distribution? Let me show you one of our example. This is your first standard deviation. This is your second standard deviation. That is nothing but your box plot here itself. Let me show you here. Okay, this is your first standard deviation, and this is your second standard deviation, and these are your outliers. I hope people are able to identify what I'm actually trying to show you. So many statisticians tend to use this particular, box plot as well to showcase the distribution. Look at this, to showcase the distribution. Maybe this box plot might be used for multiple columns as well. Normally distributed, positively skewed, negatively skewed. So if you are from stock market, okay, people tend to use something called as candlestick plot. Look at this. So I don't know, anyone have used this kind of this thing, what I can say, candlestick analysis? Okay. If you have used candlestick analysis, this is how the candlestick analysis is going to be. I hope people are able to understand what I'm actually trying to say. I think people have also seen this particular thing. Maybe you may have also used this. Okay. So this is nothing but a box plot. So advanced, you know what I can say, experts in statistics, they always like to use box plot rather than histogram. You can use anything. Array, you want to use box plot, you can use box plot. If you want to use histogram, you can use histogram. It is completely up to you. Okay. Clean and clear. Any questions? Please let me know.
No more questions, sir.
No more questions. Okay, good. So in your interview, you will be asked, okay, majority of the part on something called as, okay, central limit theorem. Okay, so central limit theorem. Guys, whenever we speak about central limit theorem is the one that we have understood right now. The terminology is different. What is meant by central limit theorem? Let me show you. Central limit theorem is all about the normal distribution that we were trying to understand. Central limit theorem is all about, okay, all about the first standard deviation, second standard deviation, and the third standard deviation. Okay. So what is meant by a first standard deviation? What is meant by a second standard deviation? What is meant by third standard deviation? So what I am asking you is, okay, to understand how this first standard, second standard, third standard deviation is going to work. So I basically require you to do a further research or analysis on this particular central limit theorem, CLT, because I'm really damn sure, okay, that this will be 100%. There will be one question in your interview. In my career, okay, every single data science interview, data analytics interview that I have dealt with, okay, there was at least one question from this particular area. So here I was speaking about something called as outliers, right? The person who is going to be really smart, a person who is going to be really bad at studies. These are called as outliers. And along with this, we also use something called as significance level. We also use something called as significance level. I also want you to do a kind of an R&D research on what is meant by the significance level and how many types of significance level we have. I want you to do it. So if I will try to teach you everything, then what you are going to learn? So for that specific reason, what is central limit theorem? And along with that, what is meant by significance level? Okay. Try to see this particular thing, because this is the same thing that I have basically told you, but this is going to give you a larger picture. This will give you a larger understanding on the same. Okay. Clean and clear. Sure. I think I'm almost done from my end. So
Thank you, Sangamesh. Hi guys. So basically, these sessions are recorded actually. So today, whatever, so maybe your e-learning portal will be ready, and all these sessions will be uploaded. And by the end of the day, you'll be getting mail regarding your login credentials. So yeah. So we'll be meeting day after tomorrow. That is Friday at same time. Okay, fine. Thank you so much. Thank you, Sangamesh. Yeah.
Thank you.
Thank you, Abhishek. Thank you, Akshay. Thank you, Amzad. Thank you, Monesh. Thank you so much. Have a nice day. Bye-bye.
Thank you. Thank you. Thank you.